Next, Dr. Ariane Ford will provide an update on how we are advancing understanding of mineral systems science using new and legacy data. Ariane is the Activity Leader for Mineral Prospectivity and Prediction and is the Module Leader for National Mineral Potential Mapping in the Exploring for the Future program. She holds a Bachelor of Science with Honours in Computer Science and a PhD in Economic Geology, both from James Cook University. Ariane joined Geoscience Australia at the beginning of the year, after more than a decade in academia and a short stint in industry. Her experience is in the analysis and integration of multidisciplinary geoscience datasets for assessing mineral potential.
So welcome everyone, my name's Ariane Ford and today I'm going to be presenting some work undertaken as part of the Exploring for the Future program that helps to support work on understanding Australia's mineral systems and mineral potential. This work is not an individual effort and relies on a very diverse team of people to deliver impactful results. Advancing our understanding of mineral systems and how to target them is a multi-stage process that involves input from across the Exploring for the Future program in terms of both data and expertise. In this presentation, I'm going to be highlighting some of the excellent work that is being undertaken, including new data releases and fascinating new results. Laura Gow and Jeff Fraser have just presented an excellent overview of the data acquisition and geological interpretation aspects of this workflow. So this presentation is going to be focusing on the latter three stages: mineral systems analysis, mineral potential mapping, and economic fairways. Once we have an understanding of the fundamental underlying geology of an area, we can ascertain which mineral systems might be present or could potentially be present given the conditions. Conceptual mineral system models can be developed based on an understanding of the key processes that have helped to shape Australia's geology and concentrated its resources. Geoscience Australia has acquired and continues to acquire large volumes of high-quality geoscience data. And in order to add value to these pre-competitive data sets, analysis can be undertaken to evaluate their predictive capacity and to help improve understanding of the formation of Australia's mineral systems. For example, this could be done through evaluating relationships between different data sets and known mineral deposits. So using a deposit database of over 900 Australian mineral deposits, spatial and temporal relationships can be used to identify possible missing deposit types for those deposit types that might be expected but are not known to be present. The spatial distribution of deposits within the convergent margin metallogenic cycles can assist in identification of tracks within the provinces that are prospective for particular deposit types. For example, some deposits are near the leading margin, such as VMS or porphyry deposits. Others occur inboard, such as intrusion-related or pegmatites, and others, such as orogenic gold, can vary considerably from proximal to distal. So we can see in this graph here that the older metallogenic cycles are characterised by a single cycle, whereas the younger ones mostly have multiple metallogenic cycles. As we can see in these two plots on the right-hand side of the slide, where the cycles in the Eastern Goldfields superterrane in the Yilgarn Craton in Western Australia, we can see mostly a single cycle, whereas if we look at the younger Tasman element in the east of Australia, we can see that there are multiple metallogenic cycles present. For more detail on this work on convergent margin metallogenic cycles, please see the presentation from David Houston. We can also evaluate relationships between continental scale data sets and the location of known mineral deposits from different mineral systems. This is an important step in understanding the evolution of mineral systems, as it allows us to test different hypotheses, and the results of the analysis can help to guide decisions about which maps to include in mineral potential mapping, as well as the feature engineering, which is basically how to make the input maps that represent spatial proxies for the mineral systems processes that are important. In the bottom left, we can see an image showing how the strength of the relationship between conductors in a magnetotelluric resistivity model and different mineral systems varies with depth. The results of the work show that a strong correlation can be observed with orogenic gold, which is represented by the warmer colours with stronger correlations. However, weaker correlations are seen for porphyry copper and volcanic hosted massive sulphide systems. The optimal depth can then be determined and plotted against the distribution of known deposits in the bottom right for predictive purposes, and these maps can be integrated into the mineral potential maps. This work is now published, and the paper and the code used in the analysis can be downloaded from the link on the slide. Another example of evaluating these relationships is shown here, where we're looking at quantifying the relationship between crustal thickness and porphyry copper endowment. So the larger map shows crustal thickness measurements globally, as well as the location of known porphyry copper deposits, which are coloured up in the smaller map by their total copper endowment. However, when these are plotted against each other, as seen in the graph, we don't observe the relationship that we might expect based on previous work, which has suggested that larger deposits are associated with thicker crust. And this forces us to rethink our understanding of the formation of porphyry copper mineral systems and how to approach mapping their prospectivity. For more detail on both of these studies, please see the presentation from Marcus Haynes. Given all of the data available and the many decades of collective mineral systems understanding, we can then start to synthesise all of this into mineral potential mapping studies that allow us to reduce the exploration search space for different mineral systems. Through evaluating relationships between different data sets and known mineralisation relating to the mineral systems of interest, we can start integrating the vast volumes of data in order to produce mineral potential maps that are both geologically and mathematically robust. The current focus at Geoscience Australia is to build on the work undertaken as part of the Critical Minerals Mapping Initiative to map the potential of sediment-hosted mineral systems across Australia, the United States and Canada. I'll talk more about this initiative in a few more slides. However, we're currently working on evaluating the mineral potential for sediment-hosted base metal systems, using both the understanding of these systems at a global scale, but also specific understanding of these within Australia. And future work is going to involve mapping the mineral potential for iron oxide, copper, gold, and alkaline rock mineral systems across Australia. As part of mineral potential mapping, we need to validate our mineral potential maps. And one really critical way of doing this is through using mineral occurrences, as they can provide an indication as to how well the maps predict known mineralisation. A compilation of all known mineral occurrences in 3 deep dive areas across Australia has been undertaken using Geoscience Australia and State and Territory Geological Survey databases, as well as extensive literature reviews. The compiled information includes discovery dates and methods, drilling information, exploration summaries, follow-up exploration work, as well as the deposit type. The compilation really highlights how many forgotten discoveries and missed opportunities are out there. And I'm pleased to announce that the mineral occurrence data sets for each of these 3 deep dive areas are now available on the Geoscience Australia portal. An extended abstract on this work is also available for download from the Geoscience Australia website, with the links for these on the slide. This compilation of mineral occurrences shows that critical minerals are found in approximately 10% of occurrences in the Barkly-Isa-Georgetown region, 10% of occurrences in the Darling-Curnamona-Delamerian region, and about 70% in the Officer-Musgrave region. Tungsten, antimony, heavy mineral sands and cobalt make up the majority of the known critical mineral instances across the 3 regions. All 3 deep dive areas are rich in cobalt. Barkly-Isa-Georgetown and Darling-Curnamona-Delamerian are rich in tungsten, heavy mineral sands. In the Murray Basin, within the Darling-Curnamona-Delamerian area, and antimony in the Barkly-Isa-Georgetown area. In addition to understanding the distribution of some of the smaller mineral occurrences, it's also really important to compile information on the larger, more economic mineral deposits. So in addition to the mineral occurrence compilation, a comprehensive compilation of information on over 900 important Australian mineral deposits has been undertaken. And this includes, but isn't limited to, information on deposit classification or mineral system using the new classification scheme of Hofstra et al., which was developed as part of the Critical Minerals Mapping Initiative. It also includes information on the age of the deposits, metal endowment, and information on lithology, host rock, and alteration. This new compilation of major Australian mineral deposits provides new insights into the spatial and temporal relationships that can help advance our mineral systems understanding, particularly for the larger, more economic systems. And this data set was used in the analysis on the convergent margin metallogenic cycles. These deposits can also be used in conjunction with the mineral occurrences to validate mineral potential mapping outputs. Another mineral deposit compilation has been undertaken for global zinc-lead deposits. And this data set provides information on the name and location of the deposits, the deposit type and mineral system, again, this information being assigned using the Hofstra et al. Deposit classification scheme, the age of the deposits, metal endowment, host rock, alteration, and mineralogy. This global compilation allows understanding Australian deposits in a global context and can provide useful insights into the formation of the different zinc-lead mineral systems and what spatial proxies might be useful for mapping these mineral systems processes as part of any subsequent mineral potential mapping. And obviously, for a global scale mineral potential mapping exercise, these deposits could be used to validate the models. The Critical Minerals Mapping Initiative is a collaboration between Geoscience Australia, the United States Geological Survey, and the Geological Survey of Canada. As part of this initiative, continental scale mineral potential maps for clastic-dominated zinc-lead and Mississippi Valley-type mineral systems were generated using both statistical and machine learning-based approaches. These systems are known to have potential for critical minerals as both a byproduct or co-product, including germanium and cadmium. The results of this mineral potential mapping work are available for download as both a journal paper and an accompanying data set, and are freely available as an open access publication. Importantly, as part of the mineral potential mapping workflow, analysis was undertaken to evaluate the relationship between individual input maps and known mineral deposits for each mineral system. This analysis helped to guide decisions around which maps to include as spatial proxies for the mineral systems processes, as well as the parameters that should be used in making them. So once we've produced mineral potential maps that evaluate the geological potential of an area, it is then important to understand the economic viability of a project in that area. The Economic Fairways Mapper combines large-scale infrastructure and geological data sets to evaluate the mining, processing, administrative and infrastructure expenses of mining operations across Australia. All of these factors are combined to provide a rapid, high-level spatial estimate of economic viability or potential that allows economic considerations to be evaluated much earlier into the initial stages of exploration. The results from the Economic Fairways Mapper can then be integrated with other tools to guide exploration to essentially provide an assessment of geological potential within the constraints of economic feasibility. The Economic Fairways Mapper has been developed to include a number of commodities, and these are listed in the table here, with the ones in italics currently being under testing and development, and we expect their release in the not too distant future. I'll now show a brief video of the Economic Fairways Mapper tool in action. The video is sped up to about 1.5 times so that you can see how quick it is to set up and run a model. The tool can be accessed from the Geoscience Australia portal, and then by clicking on the Tools option towards the top right and scrolling down to find the Economic Fairways Mapper. You can then go through and select your preferred parameters. I'm just using the default values for nickel in this video. However, as you saw on the previous slide, there are other options available and currently under development. The tool allows the user to select their preferred method of analysis, cover model, ore body geometry and grade, as well as economic parameters and a preferred output model. The results can then be downloaded in a variety of formats and compared with the results of mineral potential mapping or other exploration targeting data that can help guide decisions around the possible economic viability of a project. The National Mine Waste Assessment Project is being undertaken in collaboration with RMIT University, the University of Queensland and the state and territory governments. This project is about understanding the potential for secondary prospectivity for critical minerals through the analysis of mine waste and integrated economic modelling to support the extraction and management of reprocessed mine waste. The graph here shows the distribution of trace elements in iron oxide copper gold deposits at Olympic Dam and Ernest Henry. We can see that along with the expected high values of copper and gold for these deposits, we also observe anomalous concentration of critical minerals, including some rare earth elements. This suggests that mine waste from these types of deposits may represent an unrealised opportunity as a resource for different critical minerals. Advancing our mineral systems science is dependent on the acquisition of high-quality data that can be interpreted to produce new value-added pre-competitive geoscience datasets, such as new solid geology maps. These datasets then allow us to analyse spatial and temporal relationships that allow us to better understand the processes that lead to the formation of different mineral systems and how they can be targeted through the integration of the large volumes of data with the mineral systems understanding. Although the geological potential for the formation of a mineral deposit is critical, so too is the economic viability of the development of that resource as a mine. The Economic Fairways Mapper allows for a first-pass assessment of the economic viability of a project at early stages of the exploration process. It has also become apparent that understanding the secondary prospectivity and economic viability of reprocessing old mine waste is important for moving towards a low-carbon economy. So stay tuned for the results of this work in the future. Thank you.